Welcome back. You remember last class we talked about polygons and being able to find the length associated with sides of polygons so that we could find their perimeters and areas. And we used 4 formulas altogether. We talked about how we could find the distance and we could find the midpoints. We could do that in a one-dimensional system, in other words, where we just have a number line. And we could do that in a two-dimensional system where we had an XY coordinate axis and points that are diagonally related. You'll remember that the distance formula for this is the long one, x2 minus x1 squared plus y2 minus y1 squared. And the distance for this short one is AB is equal to absolute value of A minus B. And then the midpoints are A plus B over 2 and x1 plus x2 over 2. I know I'm blasting through this quickly, but this is what we did last class, right? So today what I want to do is take this idea of a one-dimensional system and take it one step further. If I take a ray, here's its endpoint, and then I take a second ray with the same endpoint, I produce a what? Almost. An angle, the first angle among the 3 that would be in a triangle. So this is what we're going to work on. This is now a two-dimensional space instead of a one-dimensional space like we were working on with segments. And if I want to measure this angle, am I going to measure the side lengths? How long is a ray? Infinitely long. So I'm not going to be doing any measuring of lengths along the sides here. That wouldn't help us. And I'm not going to measure like the height because the height here is different than the height here. So how do I measure an angle? What does it mean to measure an angle? Well, it's how open the mouth is, right? Like an alligator's mouth. So what we're going to be doing is we're going to be using a tool called a protractor to measure exactly how many degrees the mouth is open. And let's take a second to talk about a ruler. When we talk about a ruler, what makes a ruler? What makes something a ruler? Like this is a ruler. What does it take? In order for it to be a ruler, we got to have these little lines. And what has to be true about all these little line segments along here? They have to be evenly spaced out. So that if I mark one as 2 and one as 5, that the 3 in between those is the same as from 6 to 9. And for a ruler to work, we're going to use something called the ruler postulate, which says that a ruler has incrementally spaced units that are consistent and reliable. And now we're going to do the same thing with this thing called a protractor. So we're going from 0 over here all the way around to how many degrees on the other side? How many degrees in half a circle? Good, 180. And so what they've done is they've just split this thing up into little increments all the way along so that halfway around is 90, a quarter of the way around is 45, and these are all incrementally spaced. If I want to measure this angle, what I'm going to do, let me give myself a better angle to measure. Actually use the straight edge so it's easy to use. What I'm going to do is take this little point right in the center. Every protractor has a little spot in the center, and I'm going to put it on this point. What do we call this point in an angle? If you look at the notes you've got in front of you, it's giving us some terminology for an angle. It talks about the 2 rays with a common endpoint. Vertex. Good. A is the vertex. And if I move this protractor to the vertex, I can actually see exactly where this thing hits. This ray hits at 100, and this ray hits at 163. So if it's going from 100 to 163, how wide is this opening? How many degrees? Yeah, exactly like we did with the distance for a segment, where we said it's just the difference between the numbers absolute valued. We can say that we can find the measure of this angle by taking 100 minus 163 and doing it as an absolute value. That way it doesn't matter which one we subtract from which. This angle would be 63. And notice that if I were to do it from an interior spot here, like this one shows 80, and this one shows 23. Is that gap still 63? Yeah, so whatever part of the angle I measure, it's still going to have the same number of degrees. Let's talk a couple more details about this. This is your notes and worksheet for today. An angle is formed by two rays with a common what? Good, end point. And then we've talked about the vertex. Point A here is given to as a vertex. Which point do you think is on the exterior? Is that going to be the top one, the middle one, or the bottom one? Does that look like on the exterior of the angle? The top one. This point is outside of the angle, so this is B. That's on the exterior. Which of these 2 points, the left or the right, is on the angle itself? This one, the left, C. And then D is on the interior. It's on the inside of the mouth. Any questions on locations around an angle? Okay, while we have angles, we can classify them. You guys have used these terms before. What does it mean for an angle to be acute? Good, between 0 and 90 degrees. What does it mean if the angle has a measure of exactly 90 degrees? Right. What if it's obtuse? That means it's between 90 and good, 180 degrees, which is halfway around a circle. Now we're going to get into some terms that you might not have already known. If it's exactly 180 degrees, that's called a straight angle. And if it's more than 180, but less than 360, does anybody know that term? It's probably a new one for you. It's called the reflex. And then at the other end, we can label an angle as a zero angle if its measure is exactly what? 0. Now, as we talk about angles, it's like spinning around a circle. And so since we're getting into the idea of a circle, we have to name a circle. A circle is the set of all points that are equal distant from a single point. Here's a single point. If I go out some distance and mark a point, and I do that all the way around, do you see that I'm producing a circle? But it has to be all the points in a what? It's got to be in a plane, because if it's not in a plane, then I'm actually creating something called a sphere. It's a three-dimensional shape. But if it's all the points in a plane that are equidistant, that's a circle. Now we're looking at this protractor. This thing is called a protractor. And we talked about the protractor postulate. If degree marks are just evenly spaced around this. And we know that this point A is at what value on the protractor? What was that pointing at? 70, good. And this point B is pointed at what? 145, good. But I want to find out how far apart these two are. In other words, what the degree of the angle is. I would just take whatever A's value is minus B's value, or B's value minus A's value. It doesn't really matter. In this case, that would mean 70 minus 145, which makes negative 75, but we would absolute value that to make a positive 75. Please just erase this word consist on the end. That's just a copy paste gone wrong. Yes, sir. Sure. So we're going to be talking a lot about angles because we're going to be measuring them and describing them and combining them. So we have to figure out how to name them. Well, when I draw an angle, it has two important parts. It has something on this ray, something on this ray, and their vertex. So we'll name them by all those 3 points. If this is X, and this is Y, and this is Z, then I'm going to call this X, Y, Z. Now, when I list 3 points like this, it could be 3 points. It could be a plane. It could be a triangle. So how do I specify that I'm talking about an angle formed by those 3 points? Let's put a little symbol in front of it. Angle, X, Y, Z. So notice down here, the picture is very faint. I'm sorry about that. But if I draw this angle in, I could name this angle BAC. What would be another appropriate name for this? Very good. CAB would work. Notice that the vertex will always be in the middle. A is the most important part. There are times when I can actually just call this angle A. In this case, if I ask you to talk about angle A and I show you this picture, it's pretty obvious what I'm talking about. But if I'm looking at this shape and I said angle D, is that obvious what I'm talking about? It's not. I could be talking about the whole thing. I could be talking about angle 2. I could be talking about angle 3. It's unclear. So we can only use a single letter to name angles if it's unambiguous. What does ambiguous mean? If something is ambiguous, it's not clear what you're saying. It can be interpreted different ways. So unless it's totally clear that you're only talking about one angle, you can't use a single letter. If it's numbered, you can use that. Any questions on naming angles? Okay. Next page, please. Remember a couple classes ago, we worked with something called the segment addition postulate. And what that said is if I've got a segment, AB, with something in between like a point X, what can I say? Very good. AX plus XB equals AB. Remember that? We did some algebra problems with that. We found some values. We're going to extrapolate that exact same idea to angles. If I told you that this whole angle was 50 degrees, and I told you this top one was 30 degrees, would you be able to find how big this bottom one is? Sure, because they're going to add up together. In other words, the measure of RST. Ooh, what did I put there in front of it? M. And that tells me I'm not talking about the physical object and like picking it up and moving it. Instead, I'm saying I just want to look at the numerical value of it. Its measure, its size. But that measure is going to equal RSP, its measure, plus PST. So we've talked about this before and the importance of writing it with the characters or the letters for clarity. So here's an example problem. If you're given this information for this picture, you'd be able to say, I know that this angle is broken up into subparts. So that means that the measure of RSP plus the measure of PST is equal to the measure of RST. I know that's true because of the angle addition postulate. Now I can substitute. Instead of RSP, I can replace it with 7x minus 20. What can I replace PST with? This is RSP is 7x minus 20, but PST is different. What's PST's value? 3x plus 20. And together those equal RST. How big is RST? 140. Now I've got an algebra expression. I can solve this. First thing I should do is combine like terms. 7x plus 3x is 10x, negative 20, positive 20 makes 0. So 10x is equal to 140. I don't want 10x's, I want just 1x. What do I do to both sides? Divide by 10. And I get x is equal to 14. Easy peasy, right? Any questions on that? We'll also be asking you to do things that are dealing with angle bisectors. What does the word bisector mean? Remember we had segment bisectors where we said A, B, and M is in the segment bisector. It's splitting this exactly in half. And if we had this, and we knew that M was exactly a bisector, what could we say? What would be a new formula we could use? Good. AM equals BM or AM equals MB, because those are both the same size if this splits it in half, which is what bisect means. Now we're doing the same thing with angles. If I have this angle, what should I name this angle? How should I call it? ABC would be a great way. CBA would work. I shouldn't call this one B because there's this thing down the middle that makes it unclear. So angle ABC, it's being split by BM array, and it's being split such that BM is an angle bisector. What does that mean about this picture? Kind of like what we did here. Yeah.
ABM is equivalent to MBC.
Good. The measure of angle ABM is equal to the measure of angle MBC. Okay. Let's do the same thing down here for this example problem. Here we've got an angle ABC, and BD bisects it. So tell me in letters what's true about that. ABC has been bisected by BD. What can I write up here? Be bold. Going to be an equal sign in it. Measure of angle ABD equals DBC. Measure of angle DBC. Beautiful. We know that's true because they told us it's a bisector. Once that's true, I can substitute. If ABD is 8x plus 35, what should I put in place of DBC? What's the algebraic expression for DBC? Now to solve this, what would I do? Sometimes you'd subtract 23, sometimes you'd subtract 8x, sometimes you'd subtract 11x. In this case, we're going to end up with the next step showing a 35 only. So what did I do to this to make it become that? Subtract 8x. That leaves 3x plus 23. What did I have to do to this one to become 12 instead of 35? Subtract 23, leaving just 3x. How did I get to the next step? Divide by 3. And then I don't usually like to say 4 equals x. It's much more comfortable to say what? X equals 4. Any questions on solving that problem about an angle bisector? Okay, next slide. Now we're going to get some vocabulary going. Those of you that are doing flashcards to memorize these terms, every time I've got these capitals on top for this section, this is something we want to memorize. Adjacent angles. What does adjacent mean? Means right next to. These two angles are kind of close to each other, but they're not adjacent. These two are adjacent. So it means touching each other in a particularly specific way. Those angles to be adjacent have to be coplanar. They have to share a common vertex. And they have to share a common side. So angle 5 here and angle 6 both share this side. And they can't be overlapping. We're also going to be looking at angles that combine with other angles in a special way. Complementary angles add up to exactly 90 degrees, and supplementary angles add up to exactly how much? Good, 180. Any ideas how we can memorize this? Because you guys got to remember the difference between complementary and supplementary. Yeah. Ooh, aren't you clever? I've never heard that one before. You guys see what she's talking about? When I draw 90, there's a C in it. And when I draw 180, there's an S in it. That's super clever. I've never heard of that. Blew my nice. Anyone else see something that can work? Some people like the patterning. C in the alphabet comes before S in the alphabet. And 90 comes before 180. I've heard people say that when people give me a compliment, of course they're right, because I'm amazing. So complementary makes a right angle. And then the other one that I like is a lot like this, Bluma's idea. Complementary is a C, which is the 90. And then if I double it by taking that C and turning it down this way, it's twice as big. So the S in supplementary is twice as big as the C in complementary. Kind of the same idea. You need to find a way to keep track of those two terms and be able to distinguish them. Note that complementary angles can either be adjacent, right? Together they make 90 degrees, and thus as one angle, it becomes a right angle. Or they can be non-adjacent, and you just say the numbers add up to 90. Similarly, for supplementary, we can say that they're adjacent angles whose sums add up to 90, or just their numbers add up to 90. I'll leave this example problem for you to fill in, just identifying adjacent and complementary and supplementary angles. These are two terms that are going to come up a ton in this year. These are probably going to come up more than anything else except maybe congruent. A linear pair is two adjacent angles whose non-shared sides form what kind of angle? What do you describe as this angle? Tink, tink, tink. Close. Remember on the first page, we talked about acute angles and obtuse angles. This single angle going from here to the middle and then over to here is a straight angle. And you're right, 1 and 2 together, these two angles are supplementary. And if they're both supplementary and adjacent, they form what's called a linear pair. It makes a straight line with their non-shared sides. Two angles whose sides form two pairs of, let's see, I'm going to look at angle 6 here. Can we agree that this purple ray makes up part of 6? And this red ray makes up the other part of 6, and that these two rays make up 6. We okay with that? Now, what if I take this ray and I draw its opposite? Meaning starting from that same endpoint, I go the exact opposite direction. And then I do the same with the purple. That then draws angle 6 and angle 3 being formed by opposite rays. Angles that do that, like 3 and 6, or like 4 and 5, are called vertical angles. So 4 and blank are vertical angles. Which ones? Good, 4 and 5, and then 3 and 6. And we'll get into this later, but let's say that 4 is 100 degrees. How big is angle 6? 80. Good. How'd you know that? Because it makes a straight line, a linear pair, which means they add up to 180. So if you've already used up 100, this must be 80. Now, what about angle 5? How big is angle 5? It's going to be 100 because 80 and 100 make 180. What about angle 3 over here? 80, because these are 180 or these are 180, and these vertical angles end up being congruent. Okay, your homework tonight for homework number 7 is to finish this packet and get it in on Canvas. Before